Geometry question 2. You've got a parallelogram. If it says a parallelogram, then you can assume that it is a parallelogram. Parallelogram has opposite sides. It gives you vertices 0, 0, 6, 4, 4, and this 4, -2. Okay. All right. Looking at this, it says map the parallelogram to the space. Meaning, if I did this with the parallelogram, would it then fit back into itself? All right. And I'm going to tell you that my advice is to get a scratch piece of paper and actually trace the thing and then do what it's supposed to do. With that being said, I can't do that on the board, so I'll show you a different way. But I love, whenever I'm doing transformations, I love to use just another piece of paper, trace the axes and the shape, and then try to figure out what whatever. But let's move on. If you have a reflection across the line y equals 2 is the horizontal line right here. Okay? A reflection, which means that everything above would be the same x value that we put down, which means this point right here, which is currently 1, 2, 3, 4, above that line, which is 1, 2, 3, 4, down. Okay? And let me do, for all of the transformed points, notice points look like points, right? And so the transformed point, I'm going to make it red. That one's a blue circle so I can see which one it is. And I'm going to call this one, if this is A, then this is A minus. That means that was transformation. If I don't keep track of it, I lose what it is, where it is. So here B, which is 1, 2 above that line of reflection. B prime would be 1, 2 below. The right here, okay? And that's B prime. And again, if you don't keep track of what you're doing, like I'm doing, you're real likely to lose which points are which. Points look like points on a coordinate plane unless you label them. But C, which is currently 1, 2, 3, 4 below that line of reflection, would actually reflect up 1, 2, 3, 4 points above that line of reflection. Okay, and that is C prime. And then here's D. D is currently the origin, but it's 2 below the line of reflection, which means to reflect it across that line, it would be 1, 2 above. Just realized I did B for A. I'm actually sorry. Okay, does this map it onto itself? In other words, would it fit back into its own tracing? The answer is no. You can see that clearly it would not. It's a completely different shape. It should be one right on top of the other if it's mapped onto itself. So that's not it. So the one that I just did was B. And the answer to that is no. So B, I'm going to mark out. Notice I have to really do this for all of them. A reflection across the line x equals 2. X equals 2 is the vertical line right here. Okay, so I'm going to do the same thing, but here A, I'm going to make it go 1, 2 here, and there's A prime. Okay, and I'll put a little circle around it so I can see it. Okay, here's B. It is currently 2 to the right of that line, so I'm going to put B prime 2 to the left. Here's B prime. Okay, here's A, B, C. Sorry if these little red spots bother any of you OCD people. C, it's 2 to the right, so I'm going to go to the left, and there's C prime, and I'll do it differently so that I can see it better. And lastly, D right here is 2 to the left, so I'm going to go 2 to the right, D prime. If you notice, and hopefully you figured it out a little bit already, as you connect these transformed points, okay, you can see again that it does not transform onto itself. It's clearly a totally different shape, totally elsewhere shape. It's not in the same places. So we're going to get rid of that one and move to the next thing. The next thing is saying a rotation of 180 degrees about the point 22. This is the place where tracing are so important. Okay, but let's go through the rotation. What you've got to imagine, okay, is if this, from that point, you see this, think of it like a clock. You know that, for instance, 3 o'clock is across the clock, from 9 o'clock. 180 degrees is directly across the clock from each other. So, and that's the center of the clock, whatever the point of rotation is. And so, directly across the clock from here, which is right there, would be in this direction, okay? And you'll notice I go up 1, 2, 3, 4, back 2, up 4, back 2. Directly across from this would be down 4, forward 2. So, my new point is right here. Let me do that in a different color. My new point is right there, okay? And that would be, I didn't label it. Let's call this one A, and this one's A prime, okay? And then let's do B. Here's B right here. And you've always got to look at it from, let me get rid of these because I don't want too much writing on here. It can get confusing. It's always from the center of the clock, okay? B is currently there. I would have to go up 2 and right 1 to get to B, which means if you go down 2 and left 1, here's B prime, okay? And I'll do it the same way. All right, so there's B prime. I hope you're starting to see what's happening here, okay? I have to fix this. It doesn't look right. But there we go. Okay, if I moved C, well, C technically is where A prime is here. To get from, and remember, when you're doing rotations, you're looking at the point of rotation, the origin of rotation, like it's the center of the clock, okay? To get to C, you'd go exactly opposite the clock, which would be A. So A right here, okay, right there is C prime, all right? And then lastly, to get to 180 degrees across from this one, okay, which would be my D, it's going to be over here at B. All right, so that is the final point, which I'm doing like a little bullseye detail, but that would be what would be D prime. So the question is, does this map it onto itself? In other words, if you connected the dots, would you have the original figure back? Yes. C is the answer. If you rotated it about 0.00, it would not work, and you can try it, but you saw how to do it. That's how you work this problem. Here's your redemption. It's kind of hard to see, but let me just tell you the points that you're looking at, okay? You are looking at the points A, B, C. A is negative 5, 1. B is negative 3, 1. And C is negative 3, 5. Okay, now then, and that's this shape right here. This shape right here is, let's see, T is 1, 0. Let's do them in order. R is 3, negative 4. S is 1, negative 4. And T is 1, 0. Let me see, I wonder if I can, nah. All right, so the question is, what sequence of events would get from ABC to RST? The big thing that I want you to remember is this. The order that those letters are written is important. A has to relate to R, because A comes first and R comes first. B must relate to S. And C must relate to R. If they'd written it in a different order, then it would mean different. That also means that segment AB corresponds to segment RS, segment BC corresponds to segment ST, and segment AC corresponds to segment RT. So follow ABCD, see what you can come up with. Good luck.